Assalamualaikum and a very good day to everybody. Okay, this is the second part of the class diagram, covering on how you can actually extend whatever that you have drawn in analysis phase for your class diagram into the design phase. And in these slides and in this video, you also uh, will cover on designing of the class diagram. Here what we will cover in this slide is that not only that you will learn how to develop the class diagram, you can also look at how you can represent the relationship between the diagram, where you can show the multiplicity and also the degree. And on top of that, you'll be also looking at how you can show the relationship between the classes in terms of the data using association, aggregation, and generalization. Okay, once you have identified the classes, the next thing to think about is how you can show the relationship between the classes. Okay. It's actually a semantic connection between objects of one or more classes. Right. In UML, you represent this relationship in the form of a line. And there are several types of relationship that you can show between the objects of the classes. You can show the association, generalization, dependency, and realization. Okay, let's say you have several classes. You want to show the relationship. One way of doing it is by using a line, and you normally label it with a verb. This is to make it easy for you to read the diagram. So for example, an employee works for a department. You can also make it more meaningful by putting roles. Okay, this is roles, workers, employee. That is actually the roles that you can put in to the class diagram so that it's easy. So we know that employee is a worker. It has a role of a worker, and this class department is the employer. Okay? Right. When you have the relationship, you can actually, along the way, sometimes you want to show the degree of the class diagram. Degree means number of classes involved. Okay? There are three types that you can represent in your class diagram. One is unary, one, a relationship between objects of the same class. Or you can show the degree in terms of binary, where there are two classes involved in the relationship. And the third one is ternary. Ternary. Ternary is meaning that you want to show relationship between objects of three different classes. So this is a unary where there's only one class, object of a class, and you want to show the relationship between the same object. For example, a person is married to a person, right? So you can actually also draw it to person object and you show the relationship. But the best way is to draw it this way. This is ternary. Ternary. Ternary means that three. Okay, meaning that there are several classes together, and this is showing the relationship. As you can see here, this is only showing an example using entity classes. Remember that in the part 1 of the class diagram, you learn the stereotyping of class diagram, where you can have controller, control, boundary, and entity. And the one that you are seeing in this slide is actually showing an entity class. Alright, just now we have take a look at relationship can be represented by a link where you can label it with a word with a verb, and you can also define the role. And then secondly, you can also show the degree whether you involve only one object or two objects or three objects and so on. The third part is on the multiplicity. Okay. Or sometimes when you refer to books, it is also called the other term is called cardinality. Okay, how many instances of one class can be related to one instance of other classes. Multiplicity refers to cardinality that specify the range of numbers of objects in the class that can or must be associated with each object of class B. Right. And multiplicity, when you write it, it should be placed at each end of the association link. How do you actually see that? Okay, before I move to that, normally when you write multiplicity, there are minimum cardinality and also maximum. Okay. You can either be 1 to 1, 1 minimum to 1 maximum, 1 to many, 1 minimum to many. So it does not specify the quantity, but it should be more than 1, many to many. Okay. The minimum is many, the maximum is also many. Fixed cardinality. Maybe you want to fix it to only 2 or 4, so you can do that. Right. So whenever you write multiplicity, it should be one end, the other one, and the other one is at the other end. And as mentioned just now, normally you write the association so that it's easy to read. So if you are given this kind of diagram, how are you going to read it? You can say one movie is stopped as 0 to many videotapes. 0 to many is referred to, if you see 0 dot dot n, it's saying 0 to many. Okay, so this example here, the second one is multiplicity with fixed cardinality, meaning that rather than putting n, you put a fixed value. So how do you read this? One instructor teaches 0 to 6 section. Okay, this one is slightly different, where instead of putting many or n here, you put a specific value. So multiplicity notation is the first number is minimum, the second number is max, min, max. So as mentioned just now, normally when you write association of the class, you put the association, you label it with a verb, and also you put the room. So why you do this is so that it's easier for you and also the others to read the class diagram. For example, in this case, this is a unary relationship. Okay, why unary? Because there's only one object of class. So how do I read this? I should read one supervisor manages 0 to many subordinates. So okay, this is another example. This one is multiplicity of a ternary relationship. There are three relationships here. Right? In here, it's only showing the multiplicity. It's not showing the name of the association. For example, one part can be shipped 0 to many times. Right? One warehouse, sorry, because it does not have any um, name of the association, so it's slightly harder to read. I don't know what kind of relationship is this. As I mentioned just now to you, you normally label with a verb. Okay, and association have many multiplicity, which represent minimum and maximum. Okay, this is that's what I've shown just now. So in terms of the multiplicity, so if you see star like this, it shows many. Okay, you can have 1, 0 to many. Sometimes you put n. Okay, if you see star, it also mean many. 1 to many, 0 to 1. Okay, minimum, maximum. This is a specified range where maybe sometimes you only need certain number of multiplicity. Okay, so you can put 2 to 4. Right? So this is right. How do you read this? One teacher teach one to many courses. Right. Another form of relationship, the one that we have seen just now, is called association. There's another one which we call it aggregation. The aggregation can be used to show um, consists of relationship or is part of relationship, whereby, for example, we have two objects of classes. We have him and the player. For example, you want to show relationship of a soccer team. Okay, one team is consists of many players. Okay, aggregation have this part here. If you can see, it's labeled as a whole. Okay, and the other class is called part. Right. So one class is consists of many parts. So in the aggregation, so you see the diamond shape is not being filled, right? It's an empty diamond. So aggregation is drawn with this kind of diamond. In here it says uh, one class represent the whole. So this is the whole. This is the whole. And the other class is actually the parts. But it is loose coupling. What does that mean is that, let's say you 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 decided that you want to remove the player class. Okay, you want to have player class and you remove it, so it does not affect the team class. That is what it means by loosely coupled. Another example is that, let's say team class is replaced by a department class, and player is changed or replaced by an employee, and they have association relationship. Let's say the department is removed. Okay, so the player or the staff is still exists, does not affect. Right, that is what it means by loose couple. So another kind of relationship is called composition. It is a type of strong aggregation. It's a form of aggregation, but it's a strong aggregation with a tight coupling. So aggregation just now is loosely coupling. Okay, the whole, this part here, the whole and the part cannot exist without each other. Meaning that if you remove the whole, the part is also removed as well. So for example, we have a course registration, okay, and you have as a whole, is having a role of a whole, and course line item is the part. Okay, so this is a composition. See the diamond shape, it's being filled. Okay, this is being filled. So let's say you decided that you do not want course registration class. When you want to remove it, automatically course line item will be deleted as well. Okay, because it is very tight coupling. So be careful of that. Composition and aggregation. Okay, it has almost the same meaning. It's just that composition is having a slightly different notation where the diamond is being filled, and stronger relationship, meaning that if one is being deleted, the part is also deleted as well. Okay, the fourth relationship is called generalization. This is similar to the Java programming class where you use generalization, right? You use the word inheritance or extend when you're doing the coding, right? So you have several classes. There is a concept of superclass and subclass. The superclass is actually this one in this example, right? And it's actually the kind of notation is not like this. It's this kind of arrow. Okay, so the superclass normally will contain methods and attributes that are being shared by the subclasses. Maybe in this case, employee will have the ID number, the name, okay, whereby nurse, doctor, and pharmacist might have slightly additional attributes that is very specific to it, right? There's another example where you have an employee as a superclass, and then you can have different type of employment. One is the one that you pay by hour, the other one is the one that you pay by monthly, right? These are the subclasses. This is the superclass, and in the superclass it has all the attributes that are being shared by both of these subclasses. The subclasses is only um, different in terms of the methods, which is very specific to its own class. Alright, so by now you know the notation of class diagram. You need to put attributes and methods. You need to identify the stereotype of the class, whether it's a controller, entity, or boundary. And then later you learn about the relationship between the classes, because there are many, so you want to know how these classes are related to one another through the relationship. Relationship can be in the form of association, inheritance, aggregation, composition. Okay, now take a look at how you can actually build the class diagram. The first part is you need to set the context. So you need to identify what are the classes. A rule of thumb on how to define these classes is whenever you are given a description of a system and you try to identify what are the classes, the first thing that you can do is you need to identify in the text what are the noun. For example, student, staff, course, all those information, you need to identify it first, because that is a form, might be possible class. Okay, so identify the noun first. And then the second step is to identify the operation. You should be thinking about, okay, if I have this student class for this registration system, what kind of operation that I want the student class to have. So you can list it down. Okay? And then in terms of attributes, you should be thinking about, okay, I'm a student for this class. What kind of data that I want? So you identify the attributes. And once you have several classes together, right, you can try to identify the relationship, how each of these classes are connected. And you can also set the multiplicity, how many objects are involved in this kind of relationship. Right. So I've mentioned to you just now, this class diagram you will be using during analysis, right? And later on you'll be using it again during design phase. So when you are using class diagram during analysis, it is to think about what the business needs. So if you are trying to identify the classes. So you basically need to identify, okay, what kind of process that this business should have, what kind of data involved, right? When you are doing it during design phase, so you are thinking about how to build the business needs. So you'll be trying to extend whatever that you have drawn in class diagram during analysis phase and make it more detailed. You add more operation in the class and you want to see how they are connected to one another during the design phase. Okay, when you are doing system analysis, you are actually trying to identify or try to achieve your functional requirement. But when you are doing design phase, you are trying to make it better, not only to consider the functional requirement, but also the non-functional requirement. So you want to know, okay, if you want to have a system with a good performance, okay, what are elements that you need to consider? Okay, so major activities that involve during design phase is evolving a set of analysis. So you are basically what this is saying is that you are going to extend it to make it better, to make it more detailed, so that you capture all the functional and non-functional requirement.